music is too good right now. Fall asleep. Okay, so how do they get number 4 here? Let's see. This is the you're shortener last time you did. Let's see. You have 3 banana, 6 banana, 7, 11. So x time. Oh, let me check if the Twitch correct. I think the Twitch is correct. Okay. So every hour she pick a pile. The pile is less than K banana is all of them. Will not eat anymore. Okay. So she has to finish them within each hour. What do withins mean? Does within mean less than or equal to? This is we need to write a note for this. English comprehension. Does within means okay. So back to this. How equal 8. So she has to finish them within 8 hours. So we have to find a number K. Right? So we have like K gonna be from 1 to 11, right? It capped at 11 because let's say is either 12, right? Because let's say if the K equals to 11, then it take 1 hour to finish this, the first file, 1 hour to finish the second, 1 hour to finish the third, and 1 hour to finish the last one. So that will be sum of this, right? No, 4 hours. This is similar to 12, right? Because the sum gonna be the same. So cap at 12 is also 4 hours. So if we run through these numbers, we will find that it's like 3 hours, right? 6 hours, 7 hours, 11 hours. Maybe 36 out, right? So this is a reject. This is good. 3 plus 6 9, 9 plus 7 is 16. No, 16. Yeah, 27. 27. Sorry, my bad. Okay, math. I want to save. So on. The answer said k equal to 4. Right. So we have 1. So 2, right? Because it's eat the first one, and if it's less than the k, then eat all of them and will not eat anymore. So 2. If k is 4, then 2, 3, right? This will be 8 hours exactly. We take that. So the question here is, we know that k equal 1 is rejected. Why cannot we pick 3? One, 2, 3. And 3. Will be 9 hours. So this is rejected, right? So basically, out of all of these, you have to find the minimum k, so that the sum of the time it takes for each of these files, sum of time to finish expire, right? It must be greater than equal to h. So the first thing we can do is to look from 4i in 1, 2, max of pi, right? And then we say if the sum finish here, so we do 4j in 4 pi, right? File and file, right? Or we can just sum, right? Sum, we say that total time to finish expire, right? Can be equal to, we loop for pi and pi, right? So the time it takes to finish will be pi divided by I, right? So this is actually less to k, right? Because the question asked for k, right? So let's see. Right, so this will be sum the total time to finish x pi, right, is less than or equal to h. Then so basically we do min k equal to -1, right? Let's just initialize them with this. If min k equal to 1 or right, then if min k is greater than this numbers, or greater than, and basically we got min k equal to this number, and we return min k, right, roughly like that. Right, so we have if k equal to 3, right, it will be 3 divided by 3, 6 divided by 3, 7 divided by 3. 7 divided by 3 is what? 2. Okay, so this is, so let's say 7 divided by 3 equal to 2 plus 7 mod 3, right, equal to 1, right? So this will be so what about, do we have to redo this sum? Right, let's say the total time is 3 plus 6 plus 7 plus the total time, total number of bananas. If we divide it by 4, so it's like, no, we still have to do this calculation, right? Okay, so we do this and we do on, kn. So if we just need to find k, right, and then k is from 1 to this number, so maybe we can do binary search. Let me think. Right, so like, first we got 111, right, so then the middle number will be k equal to 6. So we do 6, then we test if this satisfies the hour, then we're gonna try lower, right? So with 6, it's 1 1 2 2. Sound right? Will be 6 hours. This is good. So then our range gonna be 6 now, right? Then we keep divided by 2. 7 divided by 2 is 3, right? 3 we have over here. This is not good, right? So because 3 is not good, then we gonna search from 3 plus 1, right? 4 to 6, right? So k gonna be what? 6 plus 4 is 10. 10 divided by 2 is 5. We do 5 over there? No. Be 1 2 5, right? 2 3, right? It's gonna be 8 hours exactly. This is good. So because we can pick this, then it's gonna be 5. And wait, no, because we can pick this, then it's gonna be 4 5, right? Similar to if we pick 1 here, right? Then the range that we want is gonna be replacing this, right? Because it's in the middle. This one, okay. So then we go to the left. Right. We go to the left and we replace the high here. Right. So now it's 9. 9 divided by 2 is 4, right? 4, yeah. So we have number 4 here is 8 hours. Good. Right? Because you can replace that. Then now 4 4 8 over 2 is 4, right? So now this is found, right? So we actually do binary search, right? So instead of that, we do, because the range is sorted, right? We can find the number and keep halving them till we found the right number. So this is gonna be, just give us O up log k and we'll O out and log k. Something like that. See in here, if we If we couldn't find the value, then we bump the low. If we found the value, then we replace the high, right? Okay, so that's gonna be done. One second, let me check the Twitter. Let's go and implement it. Python. So low gonna be 1. Identify high. I'm gonna be max file, right? Do one line. Sorry, picking my nose. Okay. So now we first gonna do similar logic here. So M gonna be goes high divided by 2. Right. I'm gonna say that while mid is not in our case here, we found that when mid is not equal to low and mid is not equal to high, and so we found okay. And we do so return M, right? Yep. And then equal to, we got to do the case where, so basically this is okay. It's the middle value. Now we check the K. Will be total time to finish each pile be equal to sum up pile be pi divided by k plus pi mod k, like that. So if the k value that we pick, if this time is less than or equal to h, then good. That means in this case 6. That means the high gonna be equal to k L. So in the case that we couldn't pick them, like k equals 3, then the low gonna be k plus 1, right? Let's try it. Might have infinite loop. Take time to finish. Just do TT for total time. Okay. You are submitting too frequently. Fine. Case 1 is k equals 10. What? Is 2 correct? Case 3 is wrong. What do we do wrong here? So let's do some printing to see, right? Maybe we did some condition wrong because whatever, right? So first we're gonna do is I'm gonna say print left k h. You wanna do tt print, then six, correct? tt 12. What? Is that correct? What is we do? Something like this. Okay. Why is it 12? 1, 6, 11, correct? Oh, I see. So we pick this. Okay, 6. Let's print out this 5. No. 51 equal. Then 2. 51. 50. 3, 1, 2, 6. What? We did that? Oh, logic here is 3 divided by 3 plus 3 more 3, right? Oh no, 3 divided by 6 plus 3 more 6. So this is like make it become 3. This is wrong. So basically we have to say that if we pick some number and that number is 6 and we see that we have 3, okay? So it's gonna be 6 divided by 3 plus 6 mod 3 gonna be 2. Wait, so we have to do this logic that let's make a function eat given speed and so given a k here and given banana. So if k greater than number of bananas greater than or equal then it's gonna be k minus bananas plus k mod bananas, right? So if k is less than banana, the number actually should be flipped. So we actually return eat banana k. There we go. So instead of this, we're gonna do eat k in pile for banana. Something like that. Oh, if the number, if the pie Coco decided which house he choose some pie banana. Pick k banana from that pie. So the pie has less than k. Okay, so if k greater than banana, so return 1. If the number of banana is actually greater than or equal to I have 6. Speed is 6. Then that is correct, right? 6 here. Then it take me 1 hour, right? To eat this, right? So if it's greater than that, then it's actually return 1. If the number of banana is more than the number of k, like this, then it's actually see, banana divided by k plus banana mod k, right? So this will be 6 greater than 3, okay, it's 1. 6 greater than equal to this 1, so equal. Okay, 6 is less than 7, so that's gonna be 7 divided 6 is 1 plus 1 is 2. 11 divided by 6 is 1, and 11 divided by 6 is 1 plus 11 mod 6 is 4, right? Is that number correct? So this 11 is gonna eat 6, and the next time it has 5, right? It has 5. Let me go to the restroom. Okay, this is actually plus eat. Okay, remain the same. The number of bananas is mod k. 1 1 2 2, good. 6 out. Then we do 1 3 6, good. Yeah, 1 3 6, good. Why is it 1 3? Right. Why is it 3? Six. That's strange. Wait, so let's go through this again. This one because k equal to 3. greater than, so this is 1, good. Now why is it 3? So this is banana is 6. So 3 greater than 6. No. Then banana divided by 6 divided by 3 equal to plus 8 3. Now the banana will be 0. Let's see. So if it is 0, if bananas 0, then return 0. Okay. So why is it 10 here? Go to 2. 2 is good. So 2 is good. So now 3 is good. Now 11. Why is it not 3? 11, 3, 3, 4. Oh, 10 is good. 10 is good. 10 is correct, my bad. But this is actually 3, 6, 3, 6, 9. Wow, so 4. This is the calculation is correct. Okay, so that make us do 4, 5, 6. That's 8 hours, good. Okay, equal to 5, good. Why does it stop now? Okay, equal to 5. Then it gives us, outside here we're gonna do k is 5 not equal to L and k not equal to H. The condition that we should do is while L not equal to H. Right, like that. Get this situation 4, 5, 6. Okay, so what did we do wrong? So let's out here, let's print L, K, H. What does it say? 666. Wow. If DT here is 8. 4, 5, 6, 8. 4, 5, 6, good. This is good. Then we pick. Then I gonna be equal to K. So why is it 6? So this means 5 is correct. If we can get 5, then we should pick I equal to k, right? My tt here is 8. Oh my god. Low, high here, bro. Because the H is also high. This is H is correct. High, low, low, high, low. Oh my god. So actually, we should just do this. Yes, I think that is correct. Go. We do okay. Let's commit this to our VS Code. We have wow. The biggest fumble is the LH, bro. And lock M. Yep, our intuition is correct. Coco eating banana. Coco eating bananas. Right, so we do description is this. But how do I copy this? Okay. Commit our stuff to the rewrite this node. This is day 2 node substack 2. Let's do that. So now we will do solution. Alright, will be from typing Checking import list. Alright. We will do what is this? Okay, right here. We put it right here. Runtime. Runtime is 300 milliseconds faster than only 5% of people. Complexity is 20 megabyte. We beat 83%. Alright. Alright, test function. File. Good. And with this, they wanna do this. Do we have them? No. 1140. This is medium. They want you to do minimum time to repair car. Okay, we got that. I'm gonna commit this. Okay. Alright, so Coco eating, not sure when if my hair is still there when I reach your age. Cool, man. Mel, what's up? Yes. Well, for sure. Let me follow you. Thank you. Thanks for hanging. Most. Oh man, just shave and give up, I guess. Okay. Thanks for chatting, Mel. I'm done with this, so now let's do some reaction, I guess. And then I look at some of the chat, some of the let's bring this up. Reaction to some of the reaction time. Okay. So we have some article on programming, right? Let's do this. How replacing let me change the text real quick. Replacing. Okay. Do video. How do we okay.
And this worked pretty well. Over time, as the rules files got...
In 2023, it was predicted that AI would replace up to 80% of developers by 2025.
In the future, we'll have AI coworkers. Those people won't even, they're not even people. They wouldn't be able to be embodied.
But this is what is actually happening. Tech companies are now hiring more developers than ever before. But this shift is not due to AI failing. Instead, it reflects companies recognizing that its capabilities were likely overestimated.
Tech giants like Meta and Google now say they're planning to have AI do as much as half of all of their coding.
Companies that previously laid off software developers en masse now appear to be reversing those decisions. Many of these so-called miraculous AI tools do not compare to the problem-solving abilities of a human.
Looks like companies are laying off the layoffs. Businesses planned around 32,000 layoffs in September. That's down.
Let me pause the background music real quick. How do you pause this thing? Okay. Okay.
27% from the same time last year.
This has put AI's ability to write code into question. So, how replacing developers with AI went wrong? In recent years, a narrative has taken hold that artificial intelligence would be ready to replace human programmers. From investors to chief executives, the idea that most software code would be written by machines by the middle of this decade was repeatedly reinforced.
The company says more than a quarter of all new code at Google is
Okay. I think the system is functioning. Hold on.
now generated by AI.
Some projections went as far as claiming that up to 80% of software development could be automated before 2026. However, the empirical evidence accumulated throughout 2024 and 2025 shows a very different reality. The initial enthusiasm for tools such as GitHub Copilot and specialized AI language models pushed many organizations toward full automation of programming. As a result, in some cases, more than 30% of innovation technology budgets were allocated to these solutions. But when these tools began to be used in real production environments, rather than controlled demonstrations, significant problems emerged. Among them were losses in productivity and an increase in error rates.
We're not saying here that AI isn't leading to be productive. We're just saying that AI tools, yes, they're here and they're being used. The payoff may be more uneven than the hype suggests.
Security vulnerabilities also appeared, and in some cases, financial collapses occurred in companies that presented AI-driven development as fully autonomous. For example,
I think it's very easy to generate code, but hey, don't give them permission to delete your table in production or something. You don't know if this vibe is correct or not. We passed the vibe check.
an academic study published in 2025 analyzed more than 500,000 code samples generated by human developers and by AI systems. The analysis focused on widely used languages such as Python, Java, and JavaScript, and the results were consistent. AI-generated code tends to be simpler, more repetitive, and less structurally diverse. These characteristics result in software that is less robust and more difficult to maintain over the long term. Although these simplifications may appear harmless, the direct consequence is a significant increase in risk. The same study found that code produced by AI contains between 20 and 45% more high-risk security vulnerabilities. These include input validation failures, improper error handling, and poor cryptographic practices.
But the big picture here is that enterprise AI spend, it's not lining up with the early narrative.
In contrast, human-written code reflects more well-grounded decisions and a better understanding of system requirements, reducing the likelihood of critical failures in production. Automated solutions, by comparison, exhibit up to 1.7 times more severe or critical errors. These findings align with industry analyses. A report by CodeRabbit revealed that AI-generated pull requests contain an average of 10.8 detected issues, compared with 6.4 in those written by humans. This difference is not trivial. Each additional error increases review, maintenance, and correction costs in later stages of development. One of the main arguments in favor of AI is increased productivity, and in simple and repetitive tasks, this promise is partially fulfilled. Studies show that junior developers can increase their delivery speed by around 30 to 35% when using AI assistants to generate basic code or templates. However, when productivity is examined in real enterprise contexts, the picture changes radically.
Seasoned engineers were actually 19% slower when using AI tools like Cursor. Instead of speeding these engineers up, the AI often gave them suggestions that looked helpful, but actually required time-consuming corrections.
Academic research and corporate reports indicate
You, just you, building your app on Base 44. Describe it. And it's real.
that more than 90% of AI-assisted development pilot projects fail to integrate stably or generate a clear return on investment. Some reasons include security issues, incompatibility with existing architectures, and the constant need for human intervention. In the case of experienced developers, several studies even show a net reduction in productivity. Senior engineers report spending between 8 and 11 additional hours per week reviewing, correcting, or rewriting AI-generated code. This effort is concentrated especially in complex systems, where contextual errors can generate cascading effects. But the most critical problem associated with AI-generated code is security. According to Veracode's Code Security Report, approximately 45% of AI-generated code contains vulnerabilities classified as critical. In languages widely used in enterprise environments, failure rates exceed 70%, while in Python and JavaScript they range between 38 and 45%.
Tech giants like Microsoft and Google are outsourcing more more and more coding to AI in a productivity push, but some new research shows the tools might not be as helpful as some expect.
But these vulnerabilities are not merely theoretical. Surveys cited by Reuters indicate that 1 in 5 security leaders reported real production incidents caused directly by AI-generated code. In some cases, organizations were forced to roll back entire deployments or apply emergency patches, with significant economic and reputational costs. But the problems are not limited to abstract statistics. There are concrete examples of companies that aggressively bet on AI-driven development automation and faced serious consequences. One of the most emblematic cases is Builder AI, a company that promised to create complete applications using artificial intelligence with minimal human intervention. Despite having raised hundreds of millions of dollars and achieving a multi-billion-dollar valuation, it was discovered that much of the work still depended on human developers.
By now, you've probably heard about Builder AI, that AI startup valued at $1.5 billion that just filed for bankruptcy, and you might even know the story about how this supposed AI company wasn't really using AI at all, just 700 Indian engineers doing the actual work.
In 2025,
Indian
the company
engineers
filed
are
for
AI
bankruptcy and reduced its
Indians.
workforce by approximately 80%, affecting nearly 1,000 employees. Another concerning case occurred in December 2025, when a developer reported a critical failure in an AI-assisted development tool with deep access to the operating system. Google Anti-Gravity AI accidentally deleted all of the contents of an entire disk drive after executing an incorrect command with a silencing flag. This incident highlighted the risks of delegating critical automations without human oversight, where a single failure can result in irreversible data loss and weeks or months of work gone. Beyond isolated errors, there is a growing technical consensus regarding the limitations of current AI models. In particular, its inability to make complex engineering decisions that require broad context and human judgment is emphasized. Automated tools perform well in clearly defined and highly structured tasks. However, they fail when interacting with interdependent architectures, legacy systems, and ambiguous business requirements, a common reality in most enterprise projects.
Prior studies from Meter have shown a more straightforward benefit to junior engineers from AI tools, particularly for simpler, well-scoped tasks. Now, this latest suggests that while it can help that group level up, it may actually be increasing reliance on senior talent because someone still needs to debug, refine, and ship the final product.
One of the most recurrent reasons for these failures is AI's inability to handle incomplete or implicit requirements. Unlike human developers who ask questions and anticipate edge cases, AI relies strictly on the information provided. This is problematic considering that more than 70% of enterprise software projects experience significant requirement changes during development. In real-world applications, a seemingly simple function such as processing payments can hide substantial complexity. In practice, it often involves dozens of business rules related to refunds, taxes, and regulatory compliance. AI cannot anticipate these complexities unless they are explicitly specified. This explains why a large proportion of automated projects end up being partially rewritten by human developers before release. This is compounded by the fact that, despite the AI hype promoted by tech companies, most artificial intelligence tools are, in general, very similar to one another.
We talked about that race between these models that, they do video or image generation. Some are better at coding than others or writing than others. They all improve, though, but they all generally do the same thing.
Cases of companies that suffered multi-million-dollar losses or even bankruptcies after blindly betting on these solutions serve as a clear warning. The real transformation does not lie in eliminating developers, but in enhancing their work through intelligent tools that reduce repetitive tasks. At the same time, human judgment, experience, and accountability are preserved in every line of code.
At Economy Media, your opinion matters to us. Subscribe and let us know what you think in the comments below.
Les Schwab changed the tire game more than 70 years ago. Today, we still believe that you should get more from less. Like exclusive tires we design ourselves means more tires made for the roads that you drive, less compromise, and we include America's best tire warranty in every tire we sell. It's more unbeatable warranty.
Okay. Okay, let's see what Reddit said or what does YouTube say? Hey, that's me. Being cheap and cutting corner leads to bad results. Who would have saw that coming? Okay, fair. Microsoft claimed that 30% of their code is written by the AI. A few months later, everything. Yeah, I remember this. Microsoft 11 AI broke. What happened with them? And these mega corporations just hire one person for modest salary, whose job it is to just sit in a room and go, no. They have completely pants on head idea like Copilot in Notepad. Sorry, forgot to send the link. Okay. This is legit. Okay. I don't think it's everyone is hyping it up. I don't think it's there yet, but could be wrong. Subscribe. This is true. The real issue isn't AI replacing development entirely, but company misunderstanding that what development actually entail. AI can generate code snippet, but struggle with system architecture, debugging complex integration, and understanding nuanced business requirement. Most AI replacing developer failure happen because management treat coding as the hard part. It's actually just the implementation step. Yep. Okay, turn on the music for a little bit. Yeah, not looking good. Actually bullish on AI, but I constantly see management with this mindset of this is easy. I could vibe code this a week myself. Wow. Yeah, this is true. Most of the time, a dev is not spent writing code. It's spent in meeting. Yeah, this is true. Career bullshitter. Wow. Nice. Laugh to you, sir. link do they post here? Can't buy RAM now. Oh no. Wow. Yeah, it's a good thing. AI, I think it's one of the tools that you should be using, not like promoting, dooming other developer. Whatever happened? What is this? Is this the same one? Yeah, this is the same one. Two separate Reddit posts, bro. All right, let's do one more LeetCode and then we'll go back to reaction. Taking iterator. What is it asking? Does Python has? I think so, right? It does have this. Is this asking to do? Oh, sorry. Need to fix this text thing. Picking iterator. Also, is it saying we have access to Hasneck next? Initialize. So they saying one, okay. Might remove the two. Do we get access to this one? Oh, an existing thing. So this thing right here has next and next. So I guess this next one here would just be cell dot iterator next. I think here will be cell dot iterator dot as next. So we should store this. So that means cell dot iterator equal iterator, right? Do we do this? Nums 0. So they're saying all the call to next and pick is valid. That means that we pick, we should just work, right? Oh, so we don't have access to nums. So we probably have to we only have hashtag and see what oh, so let's do, we have to do some value. Okay, it's gonna be cell.iterator dot, let's call this front. So we're gonna say if cell dot iterator dot has, oh actually we just call this is just a delegator. If it has next, it's next, right? So go to cell dot next basically, right? When we pick, we can cell dot front. Right? So we always pop it ourselves. So let me go pee and get some water. try our node, right? Yeah. Picking iterator. Forgot to. So one thing we could do is that we keep next the as-in iterator so that we keep track of them in our own list. Then we can pick ourselves. Okay. Is it possible to do on demand? As in as into calling it as we go. Right, so like we do pick here, we actually do next, right, to give them the value. And then when we do next here, yeah, this is what they want. I think that's what I'm getting there. We cast the next element. Yeah, that's what I thought too. Like, can you do this? Right? When you do this, maybe just return this. Right? Wow, okay. We'll take a look at that later, but check Google Guava implementation, which is okay. For sure, we gotta do this, right? So when we do this, we get the next element. Then when we pick, it's just gonna be this. And then when we call next, we actually, I see. We already moved, right? So this will be cell dot run equals cell dot next. right? And then return console.run. Right. So this is actually, yep. Next is actually return cell.iterator.next, right? So be, yep. Is it correct? Pick, I return this, and then if I do next, I actually because I already next, right? I shouldn't do that. So when should I do next? That's like, let me write some paper down. Tomorrow I gotta pay rent. Pay rent. So you have 1, 2, 3. Next, we'll make it 10. So original is here. 1, then we want to somehow pick it. So that means originally we do not do nothing. So our iterator will point to 1, and the real iterator actually this, right? And what time is it? 11:13. Okay. So we point to here, and provided they call pick, it still return this. When they call next, we actually make this become this. Right, and then when they call has next, so the real iterator is actually moved by 1, right? So first we point to nothing, our value is nothing. And if they call has next, we just do this. because we need to always, when they call pick, and we say if cell dot front, let's just initialize them with some non-value. Okay. So if not, cell dot front and cell dot has next. Cell dot iterator next. Then basically we advance our pointer. Cell dot front equal to cell dot next. Right. Otherwise, then we return cell dot front. So provided they keep picking, then now we point to here. Provided they keep picking, I'll return the next. Oh wait, what does pick mean here? Next element in the array and move the pointer to the next element. To the next element in the array. Oh, that means we look ahead. Make one pointer move to 2. And we pick it, return 2. Okay, so whatever the element that the pointer pointing at. Okay. So do that. So if I do new, set up that, I do pick, does it keep 2 or 1? So pick it, keep 1. What? Let me look. Oh, so whatever is the front, that will be the peak. Okay. So when we pick, if not having anything that mean and it has something, then we advance it, we return that. So okay. Do the next, how do we do the situation where when they call pick, right? We need to tell the iterator to go next, right? And then now we point to the element that it pointed before. So the next question is, self run is something, then that's pick, okay? And if they call, if we never pick, we keep next. If they keep next, for example, if they keep next, point here, point here. Here. Okay, so now if they call pick, right? So let they do next, they call pick. Our result should be 3. Say we do next, I also had to do something with front, right? So basically every time I call next, the if, so every time I call next, example, like I call next, then I do the same thing, cell.front, and return, right? pick without, don't call this. It'll just be this, right? If you advance, then next is this, right? So next, first would be this. If I also pick, so if I do pick, what's gonna be with those two? Like I said here, first pick, output will be 1. Yeah. So when you pick, cell dot 1 equals cell dot next. Oh, just do this. Okay. So we got 1, 2, 3. Originally the real iterator is this one. It's pointing to this. That's so confusing. Python. Make an example. Iterator. Okay. Iterator have next and next. Does it point to none of first element? No. So in this one, turn 1. iterator. Oh, so one here. Next, we turn the previous lemon. Okay, fine. So this mean whatever, next mean whatever it's pointing at. Whatever's pointing at, return that. Okay. So this return the previous, basically. So when we do next, so the order that we have can be by default point to 1, because when I do pick first, I also point here. The pointer already when I do next, because I already advanced, right? So sleepy, hold on. So let's just initialize them with none, right? And if you call peak, and if I see that my front is nothing, then go to the next one. Otherwise, and then I return cell.front, whatever the front is. Alright, so give me one. This one already go to the next one. So if I call next, go to here. If I call next, then this should advance. So this one here. So when I call next, I advance this, right? So when I call next, it will be cell.front. Iterator has to abide by the contract. This give me a previous one, right? So if cell.iterator cell.front, so that means cell.run must be equal to this. Right? Because if I do next, then I advance to here. Now, suddenly if I pick, I should give me this. Right? So now if I do pick, but the easy solution could always be that I keep calling next and then I cache myself. But it seems like they want to do it that way, right? So get some more water and thinking. Basically within this next, we gotta somehow not, and if you have a peak, it should not advance the point, right? If I do point at 1, and if I call pick, should also return 1. Now if I do next, it goes through, and then I pick, return 2, right? They called it the lamb. Now I'm tempting to play. Well, obviously the first thing we gotta do, we have to point to whatever the iterator is pointing, and the only function we can call is next. We want to say that we just return whatever here. Right, so self.iterator next. Right. So but the moment it next, so we initialize the same thing. The moment it next, we gotta say that so now when it next is already pointed to, but if you pick it next, then we gotta say that it update our front. Big, okay, good. That's it. Now if they do next, so before they do next, we gotta just return the cell dot file, right? When they do next, advance and return the previous one. So that means previous cell dot run. Then when they do next, cell dot run equal to cell dot iterator simple, bro? No, I don't think so. And oh, return previous. Yeah. So when you do next, when we do peak, we just return whatever we have. Initialize with the variable. sleepy. Maybe 10 or 15 minutes and sleep. When they call next, if our value is O. Big before next. Repeat first. The only thing we can do, initialize with this, right? So as long as they keep picking, as long as we keep picking, we should have this. But once they call next, what happened? Because we already have here. We already next. And we return front. Right? We return the value front and then we iterate the next one. Right? So we actually correct here. We actually correct here. So let's look at the value. We have 1, 2, 3. We have pick, then 1. Good. Then 1, good. Pick, then 1, good. Next, when we do next, copy this and then we return next. Okay. Has next. Oh, it had next. Oh, so we had to copy the value of has next as well. I think. So we want to do shell dot has next. Repeat, return that. We do next. Just advance that. Pick. Next. And this. Okay. So should not rely on this. What does Python has? Next last element done. We have to have a way how do we know the last element? Get the front. So basically when we call next, are you there? How do we enter the last moment to know that it has next? Because we look at the next number here, we actually advance faster than in this case we output false. That's why. We should only, so something has to be fixed. Right, so how do we fix that? How do we fix that? First next is pick one, then 1, 2. Next should be true. So what if does it do? One, two, three, four. Yeah, we fell all the has next. So we gotta figure out a way also track that. Okay, 15 more minutes, then we sleep. How do we know when we get to the end? That's the question. So when we go first, we point to this. And this guy always point ahead of me. So if they do next, what I now do is put the previous value, they call next. I return what I have, and then I point to if I pick, you go here. If equal next, the expectation is go here. You return this. But if so you do L equal 1, 2, 3. You do next L. This object is an iterator. What? Next equal L. We'll go to that, and provided that they will never call it that. And if we even initialize our stuff, right? So we just do this. Here we say that if we not initialize, and go to the next one. Okay. So beginning, we point nowhere. If they ask for peak, you just point to this. And right now, the pointer for that, and this, the real pointer point here. So now maybe we have to have another hashtag. Okay. So when they call next, we actually give the previous. Every time we call next, we actually go too fast. We actually go like that. So basically what we want is like that. That's next. The next question we need to know is if they call next. Oh. So basically when they call next, so they already here. So they call next. This one done. So basically the real iterator go ahead of us. Okay. We point here, beginning. They actually here. Big like this. And then when they call next, they go here. basic. Okay, put this to this. So this is when it says this right now when we put it, we have like right. Let's see. So let's say li. Okay. Fence it. Mix li. What? Okay. This will be what? What? Python. Okay. So basically, so if cell dot iterator dot have next we have previously is correct. So we just need to know okay, so now if it doesn't have a snack now, okay. only time when has next. We gotta track when. False. So basically, when they call next here, if cell.iterator okay, so let's do cell dot next last element cycle equals 0. Put cell dot. So will it initialize with empty? Oh, we have one. Okay. If cell dot now cell dot iterator dot has next, and we say that cell dot if basically if has next should be if less than 2. Yes. Yes, yes. Wow. Similar to the pointer. Yep. Wow. Proud of myself. But we'll look at this thing tomorrow. Premium. Empty this. What? Done. Okay, so we will have to write a Substack tomorrow and we'll have to do the review and more of the code tomorrow. Tomorrow we will review some of the code we have here, right? Substack, and I'll put some of the article reaction here. And then that's it. So maybe 7 a.m. tomorrow somehow.